Good morning, students. This is a Vipin Prohit. Welcome you all in online study of Chemistry Corner. The students, in last video we have already discussed Raoult's law for volatiles and non-volatile solutions. So today we will discuss about the graphical representation of Raoult's law for volatile solution. So we know very well about Raoult's law for volatile solutions. Pa is equal to P naught A XA, while Pb is equal to P naught B XB. And we also know the total pressure of solution is equal to sum of partial pressure of solute plus sum of partial pressure of solvent. This is the total pressure of solutions. So put the value of Pa and Pb in equation first. This is the equation first. So the total pressure Ps equals to P naught A XA plus P naught B XB by the value of Pa and by the value of Pb. So it will become this one. So but we know total mole fraction of solution XA plus XB equals to 1. So here for volatile solution of Raoult's law, here it become in two cases. Case first when P naught A is greater than P naught B. So dear students, both phases volatile solutions means in which both solute and solvents become volatiles, means can be converted into vapors phase. So here it is not necessary the total vapor pressure of solute, suppose solute is A and solvent is B, is equal to formation of solution. Clear? Formation of solutions. So it is not necessary the total pressure of A is equal to total pressure of B. Clear? Either is total pressure of Pa, either P naught A will be greater than P naught B, and either P naught will be greater than P naught A. So it become two cases. This is the case first. So how? Let's consider total pressure of solution is equal to P naught A XA plus P naught B XB. Clear? And put the value of XB. We know very well about the equation XA is equal to XA plus XB equals to 1. So XB equals to 1 minus XA, or XA equals to 1 minus XB. So first of all we will put XB equals to 1 minus XA. So it will become P naught A XA plus P naught B. Now put the value of XB equals to 1 minus XA. So it will become 1 minus XA, this one. Okay, now it will become, now solve the equation. P naught A XA plus P naught B minus P naught B XA. Okay, now total pressure of solution by rearranging the equation, P naught B plus P naught A XA minus P naught B XA. So here XA are common in both phases. So it will become P naught B plus P naught A minus P naught B. This will be convert into this one. This is the total pressure of solution. This is the case first. When P naught A is greater than P naught B. Means when the vapor pressure of A component is greater than vapor pressure of B. In other words, you can say when vapor pressure of solute is greater than vapor pressure of solvent, then the equation will become this one. This is the equation first. Clear? Okay, now come to the second case. Case second. Case second, the total pressure of solution is equal to P naught A XA plus P naught B XB. Then put the value of XA. XA means XA equals to 1 minus XB. So put the value of XA in this equation. So P naught A 1 minus XB plus P naught B XB by multiplying P naught A minus P naught A XB plus P naught B XB. So this is the total pressure of solution. So it will become P naught A plus P naught B XB minus P naught A XA. By rearranging this equation, plus side this one and negative sign this one, so this will become this one. So now we get total pressure of solution is equal to P naught A plus, here XB is common, so by taking the common of XB, then it will become P naught B minus P naught A, and XB will be common in both sides. This is the case second. This is the case second. The case second, when P naught B is greater than P naught A, means the vapor pressure of solvent is greater than vapor pressure of solute. So it will become, the equation will change into this one. So this is the equation second. Now focus on equation first. Total pressure of solution is equal to P naught B plus P naught A minus P naught B XB. While the second equation, second case of equation, PS is equal to P naught A plus P naught B minus P naught A XB. Here the common is XB, here the common is XA. Sorry, this will be XA. Clear? Okay, now on the basis of equation first and equation second, we will draw the graph and will discuss how the graphical representation for volatile solutions of Raoult's law. So the graphical representation of case first, when P naught A is greater than P naught B. Okay, when P naught A, graphical representation of case first when P naught A is greater than P naught B. So dear students, this is the equation PA equals to P naught A XA. Okay, this is the equation first for graphical representation. So dear students, this is y-axis and this is x-axis. This is x-axis, this is y-axis, and this is partial pressure of solute. This is mole fraction of solute. So dear students, we have again for equation 1, we have again two cases. First case, when XA equals to 0. When XA equals to 0, then the equation first will become PA equals to P naught A XA, and XA is equal to 0, then PA will become 0. So this is the origin of point. This will be XA equals to 0 and PA is equal to 0. And suppose this is the point. Suppose this is the point where XA equals to 1, because the value is between 0 to 1. This is the point 1 where XA equals to 1. So put this again second condition, when XA equals to 1. So put the value of XA in equation first. So it will become PA equals to P naught A XA, and XA equals to 1. So it will become PA equals to P naught A. So when XA equals to 1, then suppose draw the point here. This is P naught A, this is P naught A, and we have 2 points, so we can draw a single straight line by the one. This is the case first. Again, for case second, this is for solvent. Okay, the graphical representation for this graph, this is the representation for solute. This is graphical representation of solute, and this one is solvents. Okay, so again, this is y-intercept, this is x-axis. Okay, here PB and here XB. So dear students, again we also know PB is equal to, we also know PB equals to P naught B XB, and we also know the XB, put the value of, this is P naught B XB, and the XB equals to 0. So XB equals to 0, this point, because this is origin, when XB equals to 0, then the equation will turn into PB equals to 0, because PB not multiplied by 0, it will become 0. So this is 0 origin of point. And suppose this one the point, when XB equals to 1. This is the point when XB equals to 0. Clear? So when XB equals to 1, then this equation will become PB is equal to P naught B. And again, draw the point when XB equals to 1. This is the, suppose this is the point when P naught B form. This is the P naught B. But we also know this is the graphical representation of solute, this one is graphical representation of solvent, and we know very well the combination of solute plus solvent, will become solution. And we are going to representation of volatile solutions. So by combine the graph first and by the combining graph second. This is the graph first and this is the graph second. So by combining the graph first and second on combination, if you are going to combine these graphs, so it will become, this is the x-axis, y-axis, this is the x-axis, this will become PA, this is XA. Okay, so this is for PB, this is PB, and this will be, this is XB, this is XA. Okay, so this is the y-intercept of A, this is the y-intercept of B, this is the x-axis of A, and this is the x-axis of B. So this is the origin when XA equals to 0, this will point, because this is origin, and when XA equals to 1, suppose this is the point, and here the point, this is the P naught A. Okay, this is the P naught A, and we have 2 points, we can draw same, this one, this is the XA equals to 1, so we have got P naught A here. So when XB equals to 0, XB equals to 1, same as it is, so it will become XB equals to 1, so here the point P naught B. Now why the P naught B is lower than P naught A? Because we are going to study when P naught A, P naught A is greater than P naught B, means when vapor pressure of solute is greater than vapor pressure of solvent. So due to this, we are going to draw, this is the P naught B, and P naught B always lower than P naught A. This is the case first. So we have, again, this is origin of point, this will be 0. So this is the 2 point and this is the straight line. And we also know P, total pressure of solution, is equal to PA plus PB. So we have 2 points. So by combine these 2 points, it will become P is equal to PA plus PB. So this is the graphical representation of case first when P naught A is greater than P naught B. Okay, now we will discuss case second. We will discuss the case second when P naught B is greater than P naught A. So, dear students, the equation will become, this is the PB is equal to P naught B XB. Clear? So, this is the case second. This is the case second. Clear? Now, for graphical representation of case second, put the value of, this is y axis, this is the x axis, this is for solute. Clear? This is the solute. So, the student, when xa equals to 0, PA equals to P naught A XA. Clear? PA is equal to P naught A XA and PB is equal to P naught B XB. So, by putting the value, this is PA and this is PB. Suppose XA equals to 0, then this equation will become, when XA is equal to 0, this will become P naught A multiplied by 0, then PA will become 0. So, this is intercept. So, this is XA is equal to, here the XA equals to 1. When XA is equal to 0, this is XA is equal to 0, and between this point XA equals to 1. So, draw a point when P naught A, this one. Suppose we have 2 points, by combining these 2 points, this will become this one. This is P naught A. Clear? Now, take a second example of graph. This is y axis, this is x axis, this is x axis, and this is y axis. So, this is PB, this is XB. So, we know PB is equal to P naught B XB, and take the value of XB 0 to XB is equal to 1. So, by putting the value 0, then PB will become, by putting the value XB equals to 0 in this equation, PB will turn into 0. And when XB is equal to 1, then this equation will be turned PB is equal to P naught B. Clear? So, when XB, this is origin, when XB equals to 0, and this point when XB equals to 1. Clear? So, when XB is equal to 1, then this is the P naught B. This is the P naught B. Again, we have 2 points. By combining these 2 points, we got again a straight line. Again a straight line. This is the straight line. Clear? This is for representation of solvents. This is for solute. Okay? By combining these two graphs, we get, by combining the two graphs, we get this is the representation of A, this is the representation of B. So, this is the x-axis for B and this is the x-axis for A. Okay? So, here this is partial pressure of solute, this is partial pressure of solvents. When XA equals to 0, this is the point when XA equals to 1, where this is the point when XB equals to 0 and this is the point when XB equals to 1. Clear? So, when XB equals to 0, then XB equals to 1. So, by drawing this graph, this is the point between these two origins. By combining these 2 points, we get again a straight line, same as it is. Okay? So, when XB equals to 0, this is the 0 point for XB, and this is the XB is equals to 0, and when XB is equals to 1, so this point, this one, XA equals to 0, this is the origin of center, this is the origin of center, and suppose when XA is equal to 1, this is the origin of center. So we have 2 point again. This is the straight line, and we have this point is P naught A, this point is P naught B. Okay, now you see P naught B is greater as compared to P naught A, because we are going to discuss about case second when P naught B is greater than P naught A. Means when partial pressure or vapor pressure of solvent is greater than vapor pressure of solute. So it will become this one. But we also know P total pressure of solution is equal to partial pressure of solute plus partial pressure of solvent. Total pressure is equal to partial pressure of solute plus partial pressure of solvents. So this is the partial pressure of solvent, this is the partial pressure of solute. So by combining these 2 points, we get, this is the line, this is P equals to PA plus PB, and this is the point, P is equals to PA equals to P naught A XA, and this is the point when PB equals to P naught B XB. Clear? Same as it is this point representation for solvent. So this will represent, this line represent PB is equals to P naught B XB. This line represent PA equals to P naught A XA. By combining these two graphs, we get this graph, which represent the total pressure of solution is equal to partial pressure of solute but partial pressure of solvent. Means these graphs represent the total pressure of solute plus total pressure of solvent is equal to total pressure of solution. This is the second case of Raoult's law. Okay.